Solid waste generation, we can see here that household dominate 65% of all the solid waste generation in Malaysia, followed by commercial and institutional, and followed by industry. So total of 38,000 tons solid waste generated per day, and it is 1.17 kilogram of solid waste generated per capita. And and after that, the household waste composition as generated, we can see here that of course is as expected. It consists of 45% of food and organic, followed by uh, glass, textile, metal, e-waste, and followed by dye plastics. Of course, even though there's a single-use plastic, there's a uh, ban of single-use plastic, but still the number of plastic is still high. Yeah, most probably because of the online shopping trends. And so we can see here. So this is the in general the composition of waste in Malaysia as well as household waste compositions. So in overview, solid waste is the discarded materials from human activity, be it non-liquid and non-gaseous. And the major categories are municipal, agricultural, industrial, commercial, institutional, and construction and demolition, especially from the um, construction industry, of course. And the global increase, we can see here that from 1990 until 2020, it has increased tremendously per kilogram per person per day. And the drivers must be due to the urbanizations, income growth, as well as in industrializations. So this is in order for you to give your justification and explanation, you have to be, these are the very important points you have to include so that it can be very critical and very convincing to your justifications. And what are the sources of solid waste? You can see here that municipal, it can come from household, market, street sweepings, and industrial can be residues, packaging, sludge, ash, especially in the wastewater. And agriculture can be from, it can be from crop residues, manure, as well as agro waste from the post-harvest, for example. And institutional, it can be from the schools, office, canteens, and hospitals, also canteens. And the CAD coming from concrete, metal, woods, and plastic. So these are the main sources of solid waste that we can see the pattern in Malaysia. What about the composition of MSW, or we can call it municipal solid waste? Food waste 40 to 60%, plastic 10 to 15, paper 8 to 12, metal 2 to 5, glass 2 to 5, and it is highly depends on the income and the climate as well as collection efficiency. So that's why sometimes you can see here that certain area, especially the, maybe we can see the difference between the urban area and rural area, the collection pattern and behavior is also different. And the source composition, we can see here that so I believe I have explained this previously, and also during the class we can see here that food waste consists 44% up to 50%, or sometimes it can be up to 60% depending on the collection locations. So the characteristic of municipal solid waste, the physical characteristic, it involves specific weight, moisture content, particle size and size distribution, field capacity, permeability of compacted waste, etc. And the chemical characteristic involve proximate analysis, fusing point of ash, ultimate analysis of solid waste components, energy content of solid waste. Proximate analysis include tests such as ash, moisture content, volatile, fixed carbon, and ash determination. Usually, this one you have to send to the laboratory to determine the proximate content of a specific waste. types. And next one is biological characteristic. It includes determination of biodegradability of organic waste components, production of odors, and breeding of flies. So this is more biological. Sometimes it requires a very technical and very cultural method in terms of determining the biological properties. The physical properties of solid waste, of course, they have the density 200 to 500 kilogram per meter cube. It affects transport and landfill volume. And the moisture is very high because we are in Malaysia, 20 to 50 percentage, and the particle size affects MRF separation efficiency, which is very crucial in the landfill, and the porosity and compressibility, which will influence the gas and leachate movement. The chemical characteristic proximate, it can be uh, moisture, volatile, fixed carbon ash, and the ultimate can be the CHO and S composition, which is vital for combustion modeling. And heating value, it can be 1000 to 8000 kilogram kilo calorie per kilogram, depending on plastic or organic content. And the C over N ratio, which is very, very crucial for composting. So these are the main important parameter that you should be noticing. And the biological characteristic, high biodegradability in organic such as food and yard waste, active microbial degradation for anaerobic and anaerobic digestion, for example. A public health risk from pathogen which requires some treatment, and we can measure via respirometric index or biochemical methane potential. So in order to quantify the solid waste generation, a per capita generation equals to WC per P. So what are the determinants, which includes income, lifestyle, urbanization, industrial activity, and policy. And in Malaysia, we can see that it is 1.17 kilogram per person per day, projected to be 1.5 by 2030. So yeah, that's very alarming. And monitoring crucial is crucial for policy and infrastructure planning. And the spatial and temporal variation. So, for example, in urban and rural area, we can see that it is 2 times higher in urban area because of the higher generation of solid waste, for example. And as we discussed during the class, usually it will be higher during the festive season due to the food and packaging waste, which is 20%, 30% higher, and influenced by collection efficiency and waste tariff, if there is any, and temporal data essential for resource allocations. What about implication for system design? If we have high organic content, it should be very, very crucial and very important for composting or anaerobic digestion. Something with high calorific value, it will be more uh, crucial for refuse derived fuel potential and composition variability, which is a need for source segregation and MRF. And I believe that this is very important to make sure that it can support the circular economy and carbon reduction strategy. So that's all from me for today. So please make sure that you really go through the slides and everything, because we will get ready for assessment one. I have prepared already the question, and we will do the assessment on 20, I think on third week. Okay, on third week on Wednesday, the class time. Okay, so that's all from me. Thank you for your time. Make sure you watch this video, and I cannot wait to see you during the class. Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. I'm very, very sorry if let's say my voice is not very clear because I'm still recovering. Okay, assalamualaikum again, and thank you.